Hello viewers, in today's class we are going to take up one important problem from three-dimensional geometry, right? So here this problem, it contains both the plane and a line, right? So the problem is find the equation of the plane which passes through the point 3 comma 2 comma 0 and it contains the line x minus 3 over 1 is equal to y minus 6 over 5 is equal to z minus 4 over 4, right? So here we have to find the equation of the plane which passes through this point, right? And it contains this line. So suppose if we take the plane like this, and here we have the plane, and this plane may be denoted by the letter pi, right? Okay, and here we have the point through which this plane passes, right? So let us take this point as A, and here we have the point 3 comma 2 comma 0, right? And moreover here we are given that this plane, it contains this line L, right? And let us take the line L here, and this is the line L, right? And this plane contains this line. Now we have to find the equation of this plane, and we know that the standard form of the equation of a line is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? So this is the standard form of the equation of a straight line, right? Now if we compare these two equations, then we see that x1 is 3, y1 is 6, and z1 is 4, right? So it implies that this line L, it passes through 3 comma 6 comma 4, right? And let us take this point somewhere here, and this is this point is denoted by the letter B, and here we have 3 comma 6 comma 4, right? So this is the first conclusion which we draw from this equation of the line, right? And the second thing is that again, if we compare both these equations, we see that the direction ratios of this line L are given by A, B, C, and here we have 1, 5, and 4, right? Okay, now we know that the normal to the plane, this plane pi, it may be drawn like this, and this is the normal, right? Okay, now let us consider the direction ratios of the normal as capital A, B, and C, right? And we see that this normal vector, which is the normal of this plane pi, is perpendicular to this given line, right? So the normal is perpendicular to the line L, right? And we know that if two vectors are perpendicular, then we have the condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0, where A1 B1 C1 are the direction ratios of the first vector, and A2 B2 C2 are the direction ratios of the second vector. So here we'll take the first vector as the normal, and the second vector is the line, right? Okay, now let us consider the equation of the plane, right? Now we know that the general form of the equation of a plane is given by ax plus by plus cz plus d is equal to 0, right, where a, b and c are the direction ratios of this normal vector, right? Okay, now this plane it passes through this point 3 comma 2 comma 0, right? So the plane passes through the point 3 comma 2 comma 0, right? So it should satisfy this equation. So now we have 3a taking x equal to 3, y is equal to 2 and z is equal to 0. We have 2b plus here z is 0, so we have 0 plus d is equal to 0. So we have 3a plus 2b plus d is equal to 0, right? So this is the first condition. Now this plane pi, it contains the line L, and this point 3 comma 6 comma 4 lies on the line, right? So when this point B lies on this line L, it obviously shows that this point B also lies on the plane, right? So therefore this plane also passes through the point 3 comma 6 comma 4, right? So now this point also satisfy this equation of plane, right? So now we have x equal to 3, y is equal to 6 and z is equal to 4, right? So we have 3a plus 6b plus 4c plus d is equal to 0. Now this is equation number 2, right? Now if we subtract both these equations, that is subtracting 2 from 1, we have 3a and 3a get cancelled, and 2b minus 6b is minus 4b, and here we have minus 4c, and d also get cancelled. So we have the equation minus 4b minus 4c is equal to 0. So what we have done here, we are subtracting equation 2 from 1 to get rid of this constant d, right? So now we can simplify it. So we have minus 4b is equal to 4c. So we have minus b is equal to c, right? Let us take this equation as equation number 3, right? Okay, now let us apply this condition of perpendicular to the plane, to the normal and this line L, right? So the DRs are of the normal are A, B and C, and the DRs of the line are 1, 5 and 4. So applying this condition, we have A times 1 plus B times 5 plus C times 4 is equal to 0, right? So now we have A plus 5B plus 4C is equal to 0. Now let us call this this equation as equation number 4. Now we have to solve the equation number 3 and 4, right? Okay, so now if we take C is equal to minus B over here, then we have A plus 5B minus 4B is equal to 0, because C is equal to minus B. And now we have A plus B is equal to 0, and from here we have A is equal to minus B, right? Okay, so now we have equation number 3 and 5, and from 3 and 5 we see that we can combine both these equations to get A is equal to minus B is equal to C, right? So now finally we have the relation between A, B and C as this equation, right? Okay, So now viewers, we have this equation, that is a is equal to minus b is equal to c, right? And now let us take these three terms equal to some scalar lambda, right? Where lambda is not equal to 0, right? So a is equal to lambda and minus b is equal to lambda, so this implies b is equal to minus lambda and c is equal to lambda, right? So now we have expressed a, b and c, which are the direction ratios of the normal to the plane, in terms of lambda, where lambda is some scalar and lambda is not equal to here 0, right? So now we can write the equation of the plane which is required here, right? So now we know that the equation of a plane which passes through some point which passes through some point x1 y1 z1 is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, right? So this is the equation of a plane which passes through a point x1 y1 and z1, where a, b, c are the direction ratios of the normal. So here we have a is equal to lambda and we have x minus x1. Now x1 is the point through which this plane is passing. So here we have x1 is equal to 3 and b is minus lambda, and here we have y minus y1, so y1 is 2 and c is lambda and z minus z1, so z1 is 0, right? Now dividing throughout by lambda, as we have said earlier that lambda is not equal to 0, so now here lambda is disappeared, so we have x minus 3 minus y minus 2 plus z equal to 0, right? So here what we have done, we are dividing this equation by lambda, so we have x minus 3 minus y plus 2 plus z equal to 0, and we have x minus y plus z, and 2 minus 3 is minus 1, right? So we have x minus y plus z is equal to 1. So this is the equation of this given plane.